Good, right. So let's make a start. So welcome everybody to this webinar or tech talk hosted by ASIN. ASIN, part of the TechWorks communities, connected communities. I'm absolutely delighted actually that today we've got Steve Waldron from Vector joining us. I've heard Steve speak on a number of occasions and always entertaining, Steve. So I'm actually very looking forward to today's talk as well. Hopefully, there's a bit of controversy in there as well, because that's often a stance you take, and I do enjoy that. Makes it a very interesting view and listen as well. So Steve's going to be talking about ADAS and ADAS fit for the future. So it's really looking at how ADAS and I guess as we move towards autonomy, how this is going to transform the way we interact with our cars, and how it's going to transform our relationship with mobility, I guess. Of course, there's so many strands within this around the design philosophies, the verification, validation, data, etc., etc. So, be interesting to see how Steve directs us on this topic. Just so you're all aware, we are recording the session because we are keen to make it available on our YouTube channel, and also to promote, of course, our members, and Vector is a valuable member of ASIN. We encourage you to put your questions in the chat, and we will, as many as we can, we will address the questions at the end of the talk. If we don't address all of them, we will pick them up and endeavor to get responses to you after the call itself. And please stay on till the end because we've got some very important information about this year's conference. We run an annual ASIN conference, but this year it's a celebration of TechWorks, the parent company's 30th year. And we have a special event this year, where we bring all of our networks together. So we're very excited about that, and I'll provide some details of that towards the end of the session. So without further ado, Steve, I'm going to hand over to you, let you introduce yourself, and then let's get into the topic. Thanks, Steve.
Thanks, Gunny. Thank you, everyone. Right, well, let's get straight into it, I suggest. So I thought what might be useful for ADAS was a short recap initially of what we call the levels of driving automation, and this has been defined by the SAE. And this has become quite commonplace now to use these 6 levels of automated driving. So let's just refresh our memories on those. So we move from level 0, which is no automated driving, constant monitoring is required from the driver, to level 1 systems that we've had in place for many, many years. The vehicle can operate steering or can operate acceleration and deceleration in specific use cases. So a really nice example of a level 1 system would be, for example, cruise control, because cruise control maintains the speed of the vehicle. And then we move up to level 2 systems that we've also had for some time. The vehicle can operate steering and together with acceleration and deceleration in specific use cases. So a really nice example of this is a combination of lane keep assist and adaptive cruise control on the motorway driving. So your vehicle can maintain distance from the car in front, but also maintain itself in the lane. Important thing about level 2 is the driver must be able to resume control immediately. So if the vehicle fails to recognize the lane markings, for example, the driver has to be ready to take over immediately. There's quite a big step up to now a level 3 system, which is very similar, but is defined that the driver must be able to resume control shortly after alerted. Now, shortly after alerted is not defined by the SAE standard, but is generally interpreted to be within 10 seconds. So the vehicle is designed to recognize 10 seconds ahead when it won't be able to take control of the situation and warns the driver to take over. That's level 3. Now we come to the big interesting ones, the big step ones. Level 4 is that the vehicle can operate with no driver at all under certain driving conditions. This means, for example, on the motorway, once you move on to the motorway, you can enter the autonomous driving mode and the driver doesn't need to take over until you get back off the motorway again, or in traffic in a built up city, for example. And then the step up to the final one, level 5, is no driver is needed at all from start to finish of the entire journey. So you can basically get into the car and it will navigate using a multitude of different roads, motorway, traffic scenarios, and it will take control of that completely autonomously in all driving situations. So these are obviously the more complicated autonomous driving levels, level 4 and 5. I watched a really good TED talk all the way back in 2011, and the TED talk was by Chris Urmson. He was head of Google's driverless car program at the time. It's a really good watch. I've put the link here in the slides on his TED talk, and the key question for him was at the end, when's it going to be ready? When are we going to have fully autonomous vehicles on the road? Back in 2011, he said, well, it's a really complicated problem, but my eldest son is 11, and that means in 4.5 years, he's going to be able to get his driving license, and my team are committed to making sure that doesn't happen. So in his vision, he wanted driverless vehicles to be on the road by 2015. And of course, it is a complicated problem. It's not simply around the technology and the sensors and the image recognition and the algorithms used to compute. We also have more complex problems such as liability. Who takes liability for the vehicle if it is involved in an accident? Of course, it's not the driver anymore. Legislative framework around the government's permission to use autonomous driving vehicles on public highways. So that's what he meant by it was a really complicated problem. Where are we today? Well, we're around here. We're somewhere in between level 2 and level 3 autonomous systems. This is what's driving around on the road today. And it seems like also almost an astronomical leap to reach level 4. When we say it's a small step for man and a giant leap for mankind, well, that's kind of where we are now, moving to a level 4, a level 5 autonomous system. Let's have a look at some examples of what we have on the road today. So we've got the Ford Blue Cruise technology. Blue Cruise enables hands-free driving on many qualified what they call blue zones. And this essentially means motorways and highways. And it integrates both adaptive cruise control and lane centering to make a really pleasant motorway driving experience. Outside of the UK, it also has automatic lane changes, which are really cool. Because one of the disadvantages of this system, it's really nice, but when you come up behind a car that's moving quite slowly, you have to manually move around that car and move back into your lane. So I haven't had the opportunity to try the automatic lane change system, but I think that would be a really nice feature in this vehicle to make motorway driving quite pleasant. The one that everyone knows about, of course, is the Tesla Autopilot, which they're now calling supervised full self-driving. It uses more or less purely a camera-based vision approach. They've tried to remove LiDAR from the car using only cameras. It incorporates what they call traffic-aware cruise control, which is essentially a type of adaptive cruise control, but with more awareness of other vehicles around in the blind spots, and auto steer functions. And it can navigate city streets and respond to traffic signals. We have some additional terminology we use in the industry I'd like to introduce, and that's level 2 and 2+ and level 2++. These are really unofficial industry terms, more or less marketing terms for an enhanced level 2 systems. They haven't quite reached level 3 yet because the driver still needs to be ready to take over more or less instantly, but they're often hands-free driving features. They still require the driver to monitor the environment and intervene at any time. So the Blue Cruise from the Mustang Mach-E is a very good example of this. You're not only feet off, but you're also hands off, but you must be ready to take over immediately. When we move up to level 3, some of these systems do exist today on the roads, and they allow for eyes-off driving, but you must be ready to take over when prompted within a certain time. The first system that we know about of this was the Honda Sensing Elite, and that was released all the way back in 2021. It was a limited edition run of 100 vehicles, featuring a certified level 3 system they call Traffic Jam Pilot, which could operate basically up to around 30 kilometers an hour in heavy traffic conditions. Then in 2022, we had the Mercedes-Benz Drive Pilot, Mercedes-Benz was the first OEM with a level 3 system approved in the US in selected states only, and it handles all dynamic driving tasks in dense highway traffic. And then shortly after that, in 2024, we have the BMW Personal Pilot. It's a level 3 system available in certain markets and can offer hands-free, eyes off in traffic jam situations up to around 37 miles per hour. I'm going to show a short video, which I think is quite nice, of the BMW system.
With the BMW Personal Pilot, we are one of the first OEMs to offer a highly automated driving function. Under certain conditions, the vehicle can handle all aspects of the driving task, and the drivers can temporarily divert their attention away from the road. This allows for secondary in-vehicle activities, such as editing emails or enjoying video streaming. The level 3 feature is particularly well suited for commuting purposes. During traffic jams on motorways with structurally separated carriageways, the system can take over the driving task, up to speeds of 60 kilometers per hour. The feature is currently available in Germany in the new BMW 7 Series.
So that's the BMW Personal Pilot Level 3 system. What I really liked about this system is it drives like a traditional BMW driver and without indicating pulled out into another car in the opposite lane. So that was a really nice feature of the Personal Pilot.
BMW also.
At this point, I want to introduce EU's General Safety Regulation 2, or what's being called GSR2. And GSR2 is a type approval, so it's a legal requirement of the vehicle that mandates certain ADAS features for all vehicles sold into the UK. So whilst strictly speaking, the UK doesn't necessarily have to follow this EU regulation. In fact, in order to sell vehicles into the EU, we would need to, of course, meet this regulation. So we kind of really have to meet it by default, per se. And it mandates these following features for any new vehicle that's type approved after 2024. And it's quite a comprehensive list. So features like intelligent speed assist, using cameras to detect speed limits, and they warn you if they exceed the speed limits. In some vehicles, these are more aggressive than others. In my car, you get just a nice gentle chime if you exceed the speed limit. In other cars, it's quite more aggressive, and it has quite an unpleasant tone that it uses to warn you that you've exceeded the speed limit. Typically, you can turn this off in the vehicle, but by default, it comes back on again on every ignition cycle. Autonomous emergency braking that applies brakes to prevent collisions with other cars and pedestrians. And if you leave braking to the last minute, then this is quite a cute feature where it enables the braking for you. Emergency lane keep assisting systems to provide a little bit of steering power if you leave your lane. Driver drowsiness and attention warnings that use, typically they use a camera inside the vehicle to look at your eye and detect whether they think you're falling asleep or not. And this has differing levels of effectiveness depending on the driver. So sometimes it's really very good, and other times it can be quite inaccurate and warn you erroneously. And then we have things like event data recorders and emergency stop signals that flash lights when you brake heavily. So this also combines with the UK's Automated Vehicle Act. The Automated Vehicle Act was passed into law in 2024 and will come into full force in 2027. And this, amongst others, is paving the way for the use of self-driving vehicles on the public roads within the UK. In future, coming soon, is the EU General Safety Regulation 3, which just adds a couple more mandatory features. So we have advanced driver distraction warning. It's a more advanced version of driver alertness, also monitoring your head movements to warn you if your attention wanders for an extended period, and advanced emergency braking for not only pedestrians but also cyclists as well, to detect if they move into your path and apply the brakes in an emergency. The full regulatory framework will be fully enforced as of 2027, and as I mentioned previously, this allows the deployment of fully autonomous vehicles for at least part of your journey within a regulatory framework within the UK. We also have something that complements this, and this is the UK and the EU's what they call Vision Zero goal. And Vision Zero goal is a target to meeting zero road fatalities by 2050. And this noble cause, if you like, also instigates the introduction of more advanced driver assistance systems and safety systems on the vehicle in order to help meet this Vision Zero goal. 2026 is seeing manufacturers integrating more reliable, more user-friendly systems, moving their way from the level 2 plus and 2 plus plus up into level 3 highly automated systems. We have new features such as emergency steering assist to help steer to mitigate when a crash is imminent, crosswind stabilization to help maintain vehicle stability, which interestingly they've had on planes for many, many years. Automated parking assist, which I always find is a bit of a novel one because this was one of the very first autonomous driving systems that was ever introduced in vehicles, is the ability to park correctly, and it never seemed to get it quite right. You always ended up taking over yourself. I kind of make this analogous to 3D television. 3D TV tech has come in and gone and come in and gone as the systems change, and I find this very similar with automated parking assistance systems. And then we have other things like more advanced sensor technologies, especially in the realm of LiDAR and predictive safety features. So these are the things we'll all see coming in 2026. Outside of the UK and EU, Honda is looking to roll out its a new high-level ADAS system to its EV models in and around 2027, featuring fully eyes-off automated features. Volkswagen plans to integrate its level 2 plus plus ADAS system with its Urban Navigate on autopilot. This is essentially a traffic jam navigation system into its new smart cars in China from 2026, together with Carizon. Tesla announced a new generation of autopilot hardware, AI5 or Hardware 5, and that's scheduled for release later this year, which will be substantially more powerful than the current hardware currently being used. Kia has a number of new models announced, including the Stonic and the K4, and they'll feature advanced driver assistance systems as standard, even in their lower end models. And Toyota have new models such as the Aygo Hybrid and Urban Cruiser, featuring adaptive cruise, roadside assist, and pre-collision systems. Okay, great. So that's an example of what some certain vehicle manufacturers have publicly announced. But the question I always get asked is what's going on in China, and how are China accelerating so fast? And this is always an interesting question. Why are China? We always talk about China speed, and how are they managing to get things out so quickly? There's a number of different reasons for this. Both due to regulatory factors and geopolitical factors. So in the EU and the US, we have a much more cautious regulatory approach for advanced ADAS systems. We're very hesitant to allow these testings on public roads, for example, and we have to make sure there's a legislative framework in place for that. But China has a very supportive policy on this and really encourages the use of testing of autonomous vehicles in their urban areas. In addition to that, the US moving towards banning Chinese software and hardware components in vehicles limits the transfer of this technology from China into the US market, so that inhibits things as well. In the Chinese EV market especially, advanced ADAS systems are a key selling point, most importantly, even for entry-level models. So unlike here in the UK and EU, where the advanced ADAS systems can really be only found in the higher end vehicles, in China they're really considered to be a key selling point even in the lower end vehicles. And the last point is about data and AI. The Chinese legal framework allows for a rapid collection of vast amounts of data to train the AI models. And this accelerates development of autonomous driving features. And whereas here in the EU, we have much stricter data privacy regulations like GDPR, which doesn't allow for the collection of use of that data so easily. One of the nice features I just want to briefly mention is this urban navigate on autopilot system, and this is being introduced by automakers like BYD, NIO, and XPeng. In BYD, they call it the God's Eye platform, for example. And this can handle really very complex city traffic scenarios, traffic lights, pedestrian interactions, moving up towards level 3. It's a key feature in Chinese cities. And also incorporates some V2X communications as well. So some of the technology that's increasing rapidly in China is LiDAR systems, integrating a multi-sensor approach, connectivity to other elements, such as smart urban infrastructures. So this is very little found here in the UK at the moment, but in China they've heavily invested in urban infrastructure that can communicate in real time to the vehicles. And moving on towards fully driverless robo-taxis without a safety driver. That's still extremely uncommon here in the UK. There typically always is still a safety driver in the vehicle. But these are very common services that can be found in several cities: Beijing, Shanghai, Wuhan. And similar testing is occurring in the US, but it's much more widespread throughout China. One example we do have in the UK is in London, and an Uber and Wave collaboration inside of Ford Mach-E. And I've just put some notes here, and there's a Financial Times press article that you can read about this. It was quite interesting to note. I noticed an article published on the BBC just a couple of days ago about a testing of a driverless taxi that's moving up a one-way street in London and waking everyone. It goes up the one-way street, it gets stuck at a gate, and it has to reverse back out again. And it's waking everyone up at 4 o'clock in the morning. So these trials are not going so smoothly in the UK in every area at the moment. So that was quite an interesting article published just 2 days ago in the BBC News. What about AI? I often get asked about what's happening with AI and where do we see AI inside the vehicle. And AI has become extremely useful in many areas of software development within automotive. But one of the more interesting things for me is, where do we see AI actually performing algorithms actually inside the vehicle? And these are some of the areas we see that AI making more use actually inside the vehicle. So there's perception, using the LiDAR and the camera data to identify objects, vehicles, pedestrians, cyclists, traffic lights, moving beyond your traditional image recognition and using AI to recognize those things, making an understanding of the driving environment and lane markings. And then using AI to make decision making, planning paths, identifying risks, assessing those risks, taking proactive measures, planning on maneuvers, planning on when to change lane, and then finally using AI to take the final control, both of steering and acceleration, and possibly even emergency braking. One really nice example of AI in action in the vehicle was this demonstration I saw by Waymo at a conference I attended some years ago now. And the Waymo vehicle approaches the traffic lights, and the traffic lights have actually failed on this junction. So there's no red, amber, green light for the Waymo car to navigate. And Waymo said that without AI powering their algorithms inside the autonomous driving system, the car would have simply stopped at the traffic light and not known what to do. It would not have been able to navigate the intersection. It would have, if you like, moved to a safe state where it just stopped and took no risk by not moving through the intersection. In this example, its autonomous algorithms recognized the person of authority, the policeman in the center of the road directing the traffic, and it recognized that policeman as a person of authority, and it followed the instructions around and navigated its way through the intersection, even with the failed traffic lights. So that was a very, very interesting example for me, where basically Waymo argued that it's mandatory for them to have autonomous artificial intelligence in the vehicle in order to navigate unforeseen circumstances or driving situations that they haven't been exposed to before. So that was quite interesting for me. Just very briefly, I want to mention how the complexity of the ADAS controllers is increasing today inside the ECU itself. So in a typical ECU inside the car, we would be used to seeing something like this. For example, an Infineon Aurix controller, maybe running an AUTOSAR stack with a bootloader inside. Here is a typical example of a state-of-the-art ADAS controller, and this is the NVIDIA Orin. This can be found from their website. I've put the link below. And in this example, we have a multitude of software going inside. We have a number of different AUTOSAR stacks, plus both classic and adaptive. We have NVIDIA software. We have QNX operating systems inside. And that's even before you get to any of the application software that's actually running the cruise control, running the ADAS systems themselves. So this was really just to highlight that the complexity of these systems is really increasing exponentially in order to handle the driving scenarios that they encounter. That's it for me for today. I hope this snapshot into our experiences with autonomous driving has been interesting for you. Just some quick conclusions. So level 2 up to level 2 plus and plus plus systems are quite mainstream today, and level 3 is becoming readily available on high-end vehicles. Whereas a few years ago, the step from level 2 to level 3 was seen as the big leap. Now level 4 is considered the major challenge these days. New legislation such as GSR2 and GSR3 are driving ADAS feature increase. Even in the absence of customer requests, they're driving ADAS features into the vehicle, even in lower end models where it's becoming a legal requirement. Software is increasing in complexity, including the use of AI in place of more deterministic algorithms. And I was glad to see some people from the safety community on this call today, and I'd be interested in having further discussions with them also about the use of AI in place of our more tried and tested deterministic algorithms in the vehicle. Hardware is becoming more powerful. The ADAS controller is becoming an ecosystem all of its very own, with a mixture of different hardware and software, microcontrollers, microprocessors, and different software inside. And what does this mean? Well, ADAS is complicated and testing is, of course, hard. So a very short, shameless plug for Vector now. We're here to help. So Vector's aim is to help you develop your embedded systems and accelerate that development. We want to provide you with tools that detect your errors quicker, make your testing easier, and get you into the fast lane with ADAS development. Thank you very much. That's it from me. I will open the floor to questions.
Excellent. Thank you very much, Steve. I've got a bunch of questions myself, but before I delve into any of those, let's see how we are with time. So I've got 2 or 3 questions on the chat. First one from John. It says, thanks, Steve. Great job. So yeah, it was a great job, Steve. I did enjoy that. I thought the automated traffic jam system in the 2018 Volvo I rode in was available and legal in the UK.
I shall have to have a look. I'm not aware of that one specifically.
Okay.
But I will have to have a look. Just one comment I want to make with regard to Volvo. Volvo, I know, were the first OEM, as far as I'm aware, to say we will take liability for our vehicle when it's in autonomous driving mode, rather than trying to push the liability back to the driver or the insurance companies. So Volvo have been very brave in that regard. I don't know if it's still their stance today that they still take that stance, but I believe they were the first to take that stance to say we will take liability.
Yeah. Well, I was in a Volvo presentation. That must be 5 or 6 years ago now, when somebody asked this question about when will autonomy be on the roads. And it's really interesting response. It said, we don't think in the next 10 years. However, because the goal's been set that we want to be level 5, the rate at which we are developing technology has gone like this. So our ADAS systems are far safer now because of this push to full autonomy than it would have been if we just stuck on a trajectory which was level 2 plus. Which is an interesting observation that actually pushing the boundaries relies on us, saying that we're going to do something big and grand, and then the likes of Waymo and Wave, put us under pressure to do that.
Yeah,
So,
Waymo and Wave
God,
have quite an
please.
interesting approach that, of course, they want to make the workforce redundant essentially, by making driverless taxis. So that's always quite an interesting approach. But yeah.
Indeed, yes, indeed. So I have a question here from Dominic. Dominic says there's a lot of focus on autonomous driving across the automotive industry. However, it's much harder to make a safety case for a technology that can control steering and acceleration, I say level 1 and above, versus one that can only control brakes like AEB versus one that can only issue warnings like ISA, DDAW, etc. Do you think there's a case for applying other driver assistance technologies as protection and warning systems rather than autonomous driving systems, aiming to build the uncrashable car rather than the self-driving car?
Yeah, so I've kind of got a few opinions on this. I always get a bit nervous about safety systems, which always rely on another safety system. I've kind of seen this quite a lot. So, for example, we're not so worried if the transmission goes wrong because we rely on the brakes and the driver can step on the brakes, and then you have this like internal finger pointing where all the safety systems are relying on other safety systems. So I always get a little bit nervous about that there's a coherent safety strategy across all the systems. The other thought I have on this is we always kind of expect the technology to be perfect, right? When you have an ADAS system and it fails, like for example the Waymo system that's driving up the street in London and it's reversing back and honking its horn as it's reversing back and waking everyone up. It makes really big headlines. And of course, if there's an ADAS system that has an accident and there's a fatality, that also makes really big headlines. And part of us as humans, we want these systems to be perfect. And I'm concerned that's an unachievable goal. Personally, for me, if we see systems that statistically significantly improve accident rates and fatalities on the road, that for me is still an improvement for us as a society. We've still made an improvement. And part of that is a level of acceptance that these systems are never going to be perfect. But as long as they're better than the human driver, personally, for me, that's acceptable, that's tolerable. But I know there are other people in the industry that are more hesitant to that and will say, no, we can only put these systems in place when we can be completely reliant upon them to perform perfectly.
Yeah. I guess there's still to be defined the careful and competent driver goal. If you can justify that was careful and competent, but unavoidable injury, then we've got to figure out what that means for engineers. I had a response here from David. David from SMMT. Thanks, David. In response to the legal Volvo, if the question referred to the Volvo Pilot Assist, it is available in their models today. If that was about their testing of the L3 back in 2017-18, that feature never made it to market. Not yet, at least. So thanks, David, for that. Saves a bit of work for us to go and find out. Great. I had a question, Steve, about um, um, risk. So you talked about China speed and the Chinese really going forward. Yeah, from what I've heard, they're more open to taking a bit more risk, having less ready systems. Do we need to do that in the EU and North America? Do we need to be a bit more risky in putting features out, or do you think inherently, because of the industry we've grown up in, we can't get out of that mindset of got to make sure it's safe?
not so sure. I think we've become a little bit more open to this level of risk in the UK, I would say. So we have the Autonomous Vehicle Act, and so as of 2027, we should start to see more genuinely driverless vehicles being tested on our roads, which up until now there's always needed to be a driver present in order to take over in case anything does go wrong. And typically they don't. So if you have a look at this example that was in London just a couple of days ago, the driver in there, he was sat in the car and the people were having a go at him because his car was doing its thing. And he said, I'm not allowed to do anything. I just have to let the car do its thing. I'm sorry. So, he was there to take over, but didn't, which was kind of a little bit amusing. But I think we are becoming a bit open to the increased risk. And the reason is because we know we need to be competitive. In order to be competitive, we need to just tolerate a little bit more of this risk. And that's why as of 2027, we will probably see more autonomous vehicles without a backup driver being tested on our roads.
Yeah, that's very good. Yeah, I agree. I think there's a point now where the competition demands that we have to, to be, I wouldn't say gung ho, but a little bit more open to, to get the product out there quicker. So thanks for that. You put up at the end in your conclusion side, of course, our little plug for Vector. Related to that, I had a question about the opportunities in this area now. When we look at the UK, but maybe broader than that even. The supply. It feels like the supply chain is being disrupted, and the way that companies work together is also being challenged. Where do you see some of the big opportunities that may lie? Let's say the audience now is watching. Where could there be opportunities where we say there's capability to be built or money to be made?
So mainly, if we think within the scope of ADAS, our ADAS projects that we run are typically very different to your traditional OEM type projects where they have an OEM tier 1, tier 2 type of relationship. So typically the OEM would have sourced the hardware and the software from the tier 1. The tier 1 would have gone and maybe subcontracted some hardware or some software somewhere. In our ADAS projects especially, that does not happen at all. It's more an ecosystem of companies coming together, bringing their best bits. So Vector provides some of their software, NVIDIA provides some of their software, the OEM provides some of their software. It's much more collaborative. Who can bring the most value into this overall project? And such a thing as a tier 1 and a tier 2 really doesn't exist in our ADAS projects. And I think for me, when we look at this within the scope of ADAS, that's the value that can be brought. It's small niche companies can really bring something in here. I've got a very special AI algorithm. I've got a very special sensor fusion algorithm, for example, and they can really bring something to the party, whereas before they had to sit in this traditional tiered relationship.
Yes. Yeah, it's very interesting. I'm actually genuine for the UK, especially excited about the fact that we can build these sort of building relationships, build these ecosystems where you trust smaller, more dynamic organizations to fit. There's more questions that I've got one or two more. I'm going to do two more and then we're going to wrap up. One from Katayun. Excuse me if I didn't pronounce that right. Thanks, Stephen. Very informative presentation in terms of the roadmap for ADAS. Do you think such complex ADAS control hardware software architectures fit well in state-of-the-art embedded systems, or next levels should mandate the manufacturer to move to more complex architectures like chiplet-based architectures or high advanced technologies?
Yeah, I'm not so sure mandating those higher technologies is really necessary, because the OEM or the manufacturer of that controller will kind of move there naturally because they need the processing power. So what we've seen definitely on existing controllers like the NVIDIA Orin, which I used as my example, there are already evolutions of that coming into the marketplace. So I don't think it's necessary to mandate that. There's always been a drive throughout years and years within automotive of moving to more powerful controllers, more powerful technologies like chiplet-based. systems. I was around 25 years ago when the big furore was moving from 16-bit controllers to 32-bit controllers. That was the big excitement 20 years ago. Everyone was nervous about working with 32-bit numbers. 5 years ago, it was moving to multi-core systems. Then we had multi-core processing systems, and today it's chiplet-based systems. So I think we'll get there anyway, just driven by the ADAS features that need to be supported within those controllers.
Yeah, great. Thanks for that. I'm going to take this final question from Dan. Dan, thanks for the question. How much effort do you think will be necessary to adapt ADAS systems for different markets? For example, different driving styles in China versus EU and USA, China being much more aggressive in the driving styles.
Yeah, so interestingly for me, 2 years ago, I would have said this is quite a complicated topic because you need to, like you say, adapt. The autonomous driving systems might need to behave differently in the different markets depending on the different driving styles. Today we've got AI, and I don't want to claim that AI is the solution to all things, but there are certain things that AI do really quite nicely. And when it comes to crunching lots of learning data to learn to adapt to the different driving styles of different regions, I think this is one area that AI could bring real benefit. Not saying necessarily it will. There are obviously safety implications of applying AI to that sort of learning logic. But for me, AI would be a specific accelerator here to take massive amounts of driving data and adapt the algorithms for what's going on in that particular region. And also encountering driving scenarios that you haven't encountered on any other road. So for example, the road is closed. How do I work my way around that? The traffic lights have failed. What do I do now? AI is super slick at adapting its previous learning patterns to the new driving scenario. So I hope that we will find an application for AI in this type of area.
Yeah, fantastic, and a great question to end the session on. Thanks very much. I just want to say thank you to the audience for joining us, and also for a set of very interesting questions we posed to Steve. Thank you to Steve for a very interesting and informative presentation as always. And leaves me to say that we look forward to seeing you. I'm going to share my screen very quickly. We look forward to seeing you all, not only at the next, hopefully you can see my screen. Okay, I am screen sharing. Can you see my screen, the PowerPoint
Yeah,
slide?
I can see it now, Benny.
Perfect. Okay, good. Yeah, so you're all invited to our flagship event. We normally have a number of individual conferences for our networks. This year it's TechWorks 30th anniversary, and we're going big. So we have a large summit, Semiconductors to Systems Summit, which represents all of our members and the broader industry at the Novotel London on the 26th of August, a one-day event with multiple streams. So you're all invited to attend, but to attend. There are two other opportunities. The call for speakers is still open till the 5th of June. So invite you to go to the website. Chris has diligently been feeding that into the chat. And if you want to present, please register your interest. There are a number of opportunities and streams you can get involved with. And the other one, of course, this is a big event, a lot of showcasing, a lot of promotion. And so if you'd like your organization to be profiled, please get in touch with regards to sponsorships and exhibitions. They are doing well. We have had a lot of interest, which we're very happy about. So we want to make sure you don't miss out on that either. So with that, I don't have any more to add. There are other events, of course. Go to our events page on the website and you'll see future events, many events. And we look forward to seeing you at one of those events very soon. Thanks very much again to Steve, and thank you all for joining, and we'll see you all soon. Have a great afternoon.